Good evening, everyone. So, in today's class, we'll be talking about the last portion of point number 7 of the syllabus, which is looping. Now, looping is a programming construct, or looping statements are programming constructs which allows us to repeat a certain portion of code till a given condition is true. And as you can see, there are three types of loops mainly: for, while, and do while. Other than this, there is one more syntax for which is known as enhanced for, which we'll see towards the end of this class. And in order to move out of the loop or skip the remaining portion of the loop, we use break or continue. Again, this also comes in two varieties. Either you have a break or continue without any label, or you can use continue and break with a label. That is more useful when we have a nested loop. So enough of theory. Let's try to understand these with the help of examples. So first I'll create a folder. Let's call it loops. And then we'll see the loops one by one. So first we'll talk about while loop. So I'll just call it while demo.java. And then as usual, we'll have our class. And within the class, we'll have the main method. So, like I said, a while loop is a loop which will execute till a given condition is true. So, say for instance, I say that there is a variable int I, the initial value of which is 1, and then I say while, and then I give a condition. Let's say while I is less than equal to 5. And then inside the loop, I first print the value of I, and that is followed by I plus plus. Good evening, Akshat. So here what is happening? First, computer will come to this line, I will be equal to 1. Then the loop will start. And here first computer will check for the condition. If the condition is true, only then the computer will enter the body of the loop. If the condition is false, computer will go out of the loop. So here first time the value of I is 1. Then computer prints 1. I plus plus increases the value of I from 1 to 2. Again computer goes up, checks the condition, and this keeps on happening till the condition is true. So if I run this program, the loop is starting from 1 and it is going till 5. So if I run it, the output will be simply 1 to 5. Computer will count from 1 to 5, something like this. Now, another point to note over here is that if I go outside the loop and I try to print the value of I, please don't think that it will be 5. It will actually be 6, because since the value of I was 6, only then this condition was wrong, and only then the control came out of the loop. So if I say that, okay, outside loop I is, and then I just print the value of I, this is going to give me 6. So again, for the sake of completeness, let me run this code. So as you can see, the value of I is 6. So this is the while loop. The thing about while loop is, the main thing is that this is an entry control loop. That is, if the condition is wrong for the first time, computer is not going to enter the loop. So if I say I is equal to 10 initially, computer will not enter the loop, and straight away it will say outside loop, and then the value of I will be displayed. Something like this, outside loop I 10. That's one thing. The other type of a loop is, let me make a copy of this so we can save some time. The other type of a loop is a do while loop. So here what happens is, let me create a file for this, do while demo.java. And then I'll just copy everything inside main and I'll paste it over here. So this will save us some time. Now what I'm going to do, I'm simply going to convert it to do while. So for that, what I'll do is, First thing is I'll again make it start from 1, and then where the condition is, I'll just remove it and I'll say do, and then towards the end I'll say while I is less than equal to 5. Now here what is happening is, again, initial value of I is 1, computer goes inside, display the value of I, that is 1, I gets increased, then I is checked again, and then this keeps on repeating. The main difference, if you compare it with the previous one, that is with the while loop, is that here the body is executed first and then computer tests the condition. So in a way it guarantees that if you are using a do while loop, the body will be executed at least once, no matter what the condition is. So before I show you that example, I'll just simply run this to show that this loop will display the same output, that is 1 2 5, like it was happening earlier. And again, as usual, outside the loop the value of I is 6. Now here, if the condition is wrong for the first time, please notice the value of I is 10, computer will enter the loop, I will be 10, 10 will be displayed, I will become 11, 11 is not less than 5, and we'll go out of the loop. The thing over here is that the body is being executed once. So if I run this code, there we are, the body was executed only once and the value outside the loop is 11. So this is do while loop. The third type of loop is a for loop. So let's try that also. And here I'll say for demo dot java. Then we'll have our main method, and inside the main method, now this is slightly different. Like in the other two loops, the three parts, that is the initialization part, the condition part, and the step part, was scattered throughout the program. Here everything is at one place. So say for instance I say I is equal to 1 again, and this time the three parts will be one after the other inside the for, separated by a semicolon. So in fact, since we have to initialize, I can skip initialization over there. So I'm saying I is equal to 1, I is less than equal to 5, and then I am saying I plus plus. So the idea is still the same. This part of the loop will be executed only the once. Then computer will check this condition, that is condition is checked before computer enters the loop. Thereafter computer will go inside the loop. Right now again I am printing the value of I. It will print the value of I, it will go up, increase the value, and this will keep on happening till the condition is true. And this is also an entry controlled loop. So the thing is, do while is exit controlled, whereas for and while are entry controlled. So if I run this program again, I'm going to get the same output, that is 1 2 5. And if I try to display the value of I outside the loop, that is again I'll say outside loop I is followed by the value of I. Notice outside the loop the value of I will be 6. Now another point over here is, which we have discussed earlier also, but I'll mention it because it's related, that if I don't declare this I outside and I say that int I is equal to 1 over here, this variable I is local to this for loop, it is not visible outside the loop. That is, this line is going to give me an error, I cannot be resolved to a variable. So in case you want to access the variable outside the loop also, you'll have to declare it before. So in this case, this line doesn't make any sense. That's one thing. Now we have discussed the basic syntax of the three loops. Let's talk about something interesting, which is an infinite loop. So I'll go over here and I'll say infinite loop demo.java. And then again we'll have our main. So let's make an infinite loop with all the three constructs, that is infinite loop with a do while, with a while, and a for. So with a while loop, the simplest way to create an infinite loop is simply say while true. And within this, we can say whatever we want. So let's say I say loop. So now this is, if I run this program, the program is not going to finish. Why? Because the condition is fixed to be true. So if I run it, the program will go into an infinite loop and it will only finish if I say Control C. If you are in BlueJ, you will say Control Shift R to reset the Java virtual machine. Similarly, if you want a do while loop which is infinite, I can say do while true, and then I'll put a semicolon at the end. This will behave in the same manner, and this is also an infinite loop. Again, to terminate an infinite loop, I'll have to say Control C. And if I want to create an infinite loop with a for, it is even simpler. I'll just say for followed by two semicolons. Please understand, in a for loop, all the three parts are optional. You may give one part, two part, three part, or none of those parts depending on your requirement. So here I'll say again loop, and this is going to be an infinite loop. Again, to break it, I'll say Control C. Now, another point I would like to emphasize is that in case of an infinite loop, like in case of an infinite loop like the one which we have seen right now, computer knows that this loop is never going to end. So you cannot have anything outside the loop, not even a blank semicolon. Like see, if I give a blank semicolon, that is a null statement which does nothing. It says unreachable code. So an infinite loop cannot be followed by anything outside. That's one thing. Now, one more thing, there are certain loops which look like an infinite loop, but they are not actually an infinite loop. For instance, now this is interesting. So if I say for int I is equal to, let's say 10, and I say while I is more than 5, and then I'll say that, okay, system.out.println I, and thereafter I increase the value of I. Now, this may look like as if it's an infinite loop, but it's not actually an infinite loop. The reason is that once the value of I reaches the maximum possible value of I, the value will go to the negative, and the extreme negative value is not more than 5. Now, if I run it, you might think that it is still an infinite loop. Why? Because printing is a very slow operation. Computer is taking a lot of time to print. But if I break this over here and I remove this print statement, you'll see that, and just to confirm, I'll display a message outside. I'll say outside loop. So if I run this program now, let me run it for you. It will still take some time to count from 10 till the maximum value, and then the loop finishes. And just to confirm, I can again display the value of I outside the loop, and you'll find that it is equal to the minimum possible value of an integer. So if I display the value of I outside the loop and run the program once more for you, it will take a while, and then it says that, okay, this has reached this value, and since this value is negative, it is not more than 5, the loop finishes. Now, if you are interested in knowing why this is happening, I have made another dedicated video on this called deceptive loops, which you can watch. I'll share the link in the description below. Okay, that's one thing out of the way. Now, another thing which I would like to emphasize now is something known as a break and continue. Now, break and continue work in the similar fashion, whether it's a for loop, while loop, or do while loop. I'm going to demonstrate it with the for loop, but it will work for all the three loops because it will become a very repetitive if I do it for all the possible looping constructs. So now I'll say break continue demo.java and the usual stuff, main. So let's say I'm writing a program to count from 1 to 10. I say I is equal to 1, I is less than equal to 10, I plus plus, and then I print the value. So I'll say system.out.println I. So this is going to print from 1 to 10, and let us print it next to each other. So I'm removing println and I'm adding a space at the end, and when everything is over, I'll just give a new line. So if I run this program right now, I'm going to get numbers from 1 to 10 next to each other, something like this, 1 to 10. Now here what is happening, the computer is running the entire body of the loop. There is something known as continue. So for example, if I say if, now usually continue and break is given inside an if, because otherwise there's no point in having the entire loop. So the idea over here is, like for example, if I say if I modulus 2 is equal to 0. Now I modulus 2 will be 0 when, for every second number, that is when I is equal to 2, I is equal to 4. And I'm saying that if I modulus 2 is equal to 0, continue. So what continue does is it skips the remaining portion of the loop, which means that this line will not be executed when I modulus 2 is equal to 0. In other words, this code will now skip all the even numbers. Let me run this code for you. So if I run this code, you'll see that all the even numbers are skipped. So continue skips the remaining portion of the loop. So I'll say continue skips the remaining portion of the loop. Spelling LOOP. So that's one thing. Now there is something known as a break. So what I'll do now is I'll just comment it out, and or let's say I modify this code. If you want to see it again, you can always rewind. So let's say I change the condition. I say if I equals 7, and instead of continue, I say break. Now what happens is that computer will start counting from 1. It is supposed to count till 10, but as soon as I reaches 7, I'm saying break. Now break aborts the loop. That is, it will go, the control will go rather from this line straight away to the line following the loop in which it is given. So here, once the computer reaches 7, the loop will be aborted and computer will go out of the loop. So if I run it, there we are, 1 2 3 4 5 6, and at this, when the value of I becomes 7, we'll go out of the loop. So this is an example of a simple break as well as a simple continue. Now there is a possibility that the loop is nested. That is, we have a loop inside a loop. Say for instance, I'm just going to decrease this value. If I say that this loop is running from 1 to 5, I remove this stuff, and then I have one more loop outside this. So I'll just cut it for the time being. I say int x is equal to 1, x is less than equal to 5, x plus plus, and then within this loop I have one more loop. So, and let's say I display both the values. So I am saying the value of x, I'll say x colon followed by the value of x, and then I'll say I colon followed by the value of I. And again, to avoid clutter, I'll say println, and we'll remove this trailing space. So in each line, we are displaying the value of x followed by the value of I. If I run the program right now, it's going to run 25 times. Inner loop is running 5 times, and whatever is happening inside the loop is being repeated 5 more times. Now see, if I run this, the total number of times the body will be executed is 25 times. So this is running 25 times. So 1, 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on. Oh, okay, sorry. No, it's correct. X is equal to 1, x is less than equal to 5, x plus plus, I is equal to 1. Okay. So this is one thing. Now, if I say that, okay, over here, I say break. If I is equal to 2, I say break. Now, please understand this break is going to break from this for loop. That is, break will break from the most recent loop. It's not going to break from this loop. But there is a way by which you can make it break from this loop, and that is by using a label. Now, label is a way, is a kind of a marker for a given line. Like, say, for example, I say over here, outer colon. So anything followed by a colon is a marker. So I'm telling the computer that, okay, this line is marked. So outer colon over here. And if I say break, okay, first let me run this without the labeled break. So the label can remain, that's not a problem. We can have a label over here. So if I run the code, see the program is going out. And if I say break, please note x is equal to 1, 2, 3, 4, 5, the outer loop is running. But if I say over here break outer, computer will break out from this loop. That is, once x is equal to 1, I is equal to 1, and the value of I reaches 2 for the first time, computer is going to stop the loop. So if I run it, see, there we are. Just after one iteration, the value of I became 2 and we broke out from the outer loop. Sometimes for clarity, we have a line break over here so it looks nicer. And like, you can say inner also if you want. We are not using it, but the idea is the same. Now we have labeled both the loops and you can break from outer or inner as per your requirement. And just like break outer is breaking from the outer, continue outer will continue the outer loop instead of inner loop. So that's how break, continue, break with a label, and continue with a label works. And I believe with this we have talked about all the three main loops. Now, why I'm saying main loops? Because there is one more syntax of a for loop which is known as an enhanced for. Let's have a look at that also. For that, what I'll do is I'll close this and I'll have one more file and we'll call it enhanced for demo.java. And inside this, let's have one more loop. Okay. So let's say I have an array. Now we'll go into the details of an array, but I believe that most students know what is an array. So let's say I have an array which is storing some values. Let's say 9, 8, 7, 6, 5, 4, 3, 2, 1. And in many programs, it happens that you have to traverse the entire array. That is, you have to access all the array elements one by one. So the most common way to traverse an array is we say that, okay, we want to loop from I is equal to 0 till I is less than array name dot length. And then we'll say I plus plus. And within this, we'll say system.out.println a of I. This is the usual method. So if I run it, computer is going to display the entire array 9, 8, 7, 6, 5, 4, 3, 2, and 1. Something like this. Now, there is another way of doing it because this is so common in programming. There is another way of doing it, and that is a simplified version of this known as an enhanced for. So there I can say, for example, int, let's say v for value, and then I say colon a. And there is no need to say a of I can simply say v. So the idea is that here the variable v, which is also an integer variable, is assuming all the values of the array a one by one. The output is not going to change, but this looks better and is slightly more compact in nature as well. So this is something known as an enhanced for loop. And with this, we have covered all the topics mentioned in the syllabus. Obviously, we'll be doing questions based on these later on, but as far as the semantics are concerned, we have talked about everything. So this is all for the today's live stream. In the next live stream, we'll be talking about methods and constructors, and we'll be taking a deep dive into those topics. Plus, we'll have one fairly elaborate programs to demonstrate this part, that is abstractions for complex user defined operations on objects. So that's all for today. Thank you.